Task number 3, port scanning. Who is listening? Earlier, we used -sn to discover the live hosts. In this task, we want to discover the network services listening on these live hosts. By network service, we mean any process that is listening for incoming connections on a TCP or UDP port. Common network services include web servers, which usually listen on TCP port 80 and 443, and DNS servers, which typically listen on UDP and TCP port 53. By design, TCP has, oh, there you go, we have the number. In the previous room, we explained this number. Just go watch the previous room. 65,535 ports, TCP and UDP. And the same applies to UDP. So multiply by 2. How can we determine which ports have a service bound to it? Let's find out. Scanning TCP ports. The easiest and most basic way to know whether a TCP port is open would be to attempt to telnet to the port. So basically we use telnet to that port. We have a telnet room also, so just check it out. If you are inclined to scan with a telnet client, try to establish a TCP connection with every target port. In other words, you attempt to complete the TCP three-way handshake with every target port. However, only open TCP ports would respond appropriately and allow a TCP connection to be established. This process is not very different from Nmap connect scan. We have the connect scan. The connect scan is S and then T, basically TCP. As U, uppercase U, it's UDP. It tries to complete the TCP three-way handshake with every target TCP port. If the TCP port turns out to be open and Nmap connects successfully, Nmap will tear down the established connection. In the screenshot below, our scanning machine has the IP address and target system has TCP port 22 open and port 23 closed. In the part marked with 1, you can see how the TCP three-way handshake was completed and later torn down with a TCP reset ACK packet by Nmap. The part marked with 2 shows the connection attempt to a closed port and the target system responded with a TCP restored ACK packet. Right, so we see here we have the first section and the bottom 2 is the second section. Here we can see these relevant TCP reset acknowledgement for both requests, right? Cool. SYN scan stealth. Unlike the connect scan, which tries to connect to the target TCP port that is complete a three-way handshake, the SYN scan only executes the first step. It sends the TCP SYN packet. Consequently, the TCP three-way handshake is never completed. So basically, in the first one, sends basically the SYN, it receives the SYN ACK and then reset, right? For the second one, we have the SYN, right, from our host to that one, but we don't get the SYN acknowledgement. The SYN scan only executes the first step. It sends the TCP SYN packet. Consequently, the TCP three-way handshake is never completed. The advantage is that this is expected to lead to fewer logs, as the connection is never established, and hence it is considered a relatively stealthy scan. You can select the SYN scan using -S and uppercase S flag. In the screenshot below, we scan the same system with port 22 open. The part marked with 1 shows the listening service replying with the TCP SYN ACK. We've seen this. However, Nmap responded with a TCP reset packet instead of completing the TCP three-way handshake. Yep. The part marked with 2 shows the TCP connection attempt to a closed port. We let's say we call it, we request it with SYN, but the port is closed. In this case, the packet exchange is the same as in the connect scan, scanning UDP ports. Although most services use TCP for communication, many use UDP. Examples include DNS, DHCP, NTP, Network Time Protocol, as Nmap, Simple Network Management Protocol, and VoIP, Voice over IP. Messenger, maybe. WhatsApp, maybe. UDP does not require establishing a connection and tearing it down afterwards. Furthermore, it is very suitable for real-time communication, such as live broadcasts. All these are reasons to consider scanning for and discovering services listening on UDP ports. Nmap offers the option as uppercase U to scan for UDP services. Because UDP is simpler than TCP, we expect the traffic to differ. The screenshot below shows several ICMP destinations unreachable. Port unreachable, you can see them in black. Response and Nmap sends UDP packets to closed UDP ports. Yep, so we can see them destination unreachable. Nope. We tried to request, but no thank you. Limiting the target ports. Nmap scans the most common 1000 ports by default. However, this might not be what you are looking for. Therefore, Nmap offers you a few more options. So basically, if you don't use any flag, by default scans the most common used 1000 ports. -F is for fast mode, which scans the 100 most common ports instead of the default 1000. But this is what you want. -P with a range. Allows you to specify a range of ports to scan. For example, this one, it scans from ports 10 to 1024, while -P-25 will scan all the ports between 1 and 25. Note that -P- scans all the ports, meaning this entire number and the same number that we've seen up here. So when you use -P-, you will scan all 65,535 ports. That scan will take a while. This is another way to write it. And it's the best option if you want to be as thorough as possible. Rarely you need to scan all of them. So yeah. Summary option. We have the flags that we just read about. So ST, TCP, connect, scan, complete three-way handshake. SS is the SYN scan, only first step in the three-way handshake. SU, UDP scan. F, uppercase F is fast mode, scans the 100 most common ports. And then -P with a range scans basically the specified range. If you don't specify it, or you use this one, it will scan all of them. Let's open the split view in order to answer the questions. Answer the questions below. How many TCP ports are open on the target system? So we go like nmap st. I don't know why I always say nmap. All right. And then we go like 10, 82, 153, 68. Now this being, I think it's a trick question, and I'll go for every. No, I will not go for every port. I will just go like this. Let's see how many we find it. How many? 5. If the answer is not 5, then we have to go. We have to go even bigger. P. Wait. This is a mistake. P. Let's go for this. So basically they are 6. 6. These are the ports. Let's go up here a bit. That's strange because it didn't get 17. It got this one with fast, meaning that we don't specify the P, which will scan the top. So this one scanned the top. Yeah. So basically, this is the thing. -F, uppercase F, scans the 100 most common ports. This, if you don't specify any command, Nmap will scan the 1000 top most common 1000 ports. So it's not from 1 to 1000. They are the most common used ports. This is a very good example to see if we use -uppercase F, that here we have above 1000, right? And this one scans only to 100 if we think like that, but it's 100 most common ports. This is HTTP. It's a very common port, right? And here, if we use the command scan everything, it appeared also port 17 open, which over here we don't see it. So there are 6 ports. There are 6 ports open in this machine. Find the listening web server on that and access it with your browser. What is the flag that appears on its main page? Let's see. 168. We'll go like this. 10. 82. 153. 68. Colon. 008. This is the secret page. So perfect. We just scanned. Let's do a very quick summary. So for the first question, how many TCP ports are there? Obviously, TryHackMe is a bit tricky, which is very good because it just makes your mind to think outside of the box. If you use the commands like you've seen up here, TCP, like here, right? Only with the ST, you will get this 5. Actually, let's use that command. Now we get everything because we see the top 1000. Okay, but if you use again with the -F, we get nothing. Cool. So anyway, if you use this command, we get only 5. These are the displayed TCP open ports on our target if we are scanning for the top 100. But if we don't use this flag, or we just use, if we don't use this flag and we use the default command, scan for TCP ports on this target, Nmap will scan the top 1000 default most common 1000 ports and will give us the 6th, which is hidden over here, port 17. But we can do this P. Now, in our case, this one works very fast, but almost always it's a type of a scan that it takes much more time. So this simple command will give us the answer. So we have 6 ports, and then we see in the port 8008 we have the HTTP opened on our target. Well, we just launched a web browser under that IP, colon to HTTP port. Just access it and you will find out the flag. That's it.